Hello and welcome to This Is Us. I'm Becca King-Reed. This week we're at NASA visiting the Ames Research Center at Moffett Field. This building is sustainability base. It's a building so smart it can sense how much energy is being used inside and adapt to weather, to work schedules, even to the seasons. It's a good example of how space technology can make a difference right here on Earth, and we'll see a lot more space technology throughout the show. We'll also meet 3 local scientists who are exploring the universe. Dr. Sandra Faber, who played a critical role in the success of the Hubble Telescope, Dr. Natalie Battaglia, who's discovering inhabitable planets as a part of the Kepler Mission, and Dr. Chamitoff, an astronaut from San Jose, who was lucky enough to fly on both the Discovery and Endeavour space shuttles and spend 6 months on the International Space Station. We've got some great stories to share, and it all starts now.
This is us.
Welcome back to NASA. David Duster-Haas and I are standing in front of the world's largest wind tunnel. Tell us about this wind tunnel. How large is it?
This is the intake from the 80 by 120 wind tunnel. It's actually the size of a football field laying on its side. The wind tunnel test section itself is 80 foot by 120 foot, and we can actually test wind tunnel models up to 110 mile an hour in that area.
Well, so that's like hurricane force winds.
That's like hurricane force winds, absolutely.
Now, what kinds of things are tested in a wind tunnel?
We test all sorts of things, like in addition to aircraft models, we'll also test things like truck trailers for aerodynamics. We'll also test models of wind turbines, for example, to evaluate the performance of wind tunnels. And then importantly, we also evaluate, one of the critical things we do here is operate and test for helicopters and see how the rotors perform in forward flight.
In a wind tunnel as large as this, you could actually bring a full-scale model in.
We do, and actually we do a lot of full-scale models because it's important sometimes to see the effects that the full-scale model might see in structural effects and deformations that it might see in full-scale flight. So it's one of the big reasons why the full-scale tunnel is so important.
So the concept is, instead of watching a thing as it moves through the air, you move the air over the thing.
That's right. By holding it stationary, we can measure the forces that the wind generates on the model. We can get the lift performance, drag performance, and other moment coefficients off of the model, so we can evaluate those in the design of the aircraft and see how it performs.
Now, you mentioned you tested a truck. Is that just to see how much wind it could take, like how fast it can drive down the road?
No, actually, it was actually trying to improve the drag performance so that you use less fuel in future truck driving. So the amazing amount of fuel that we use in trucking things around the country, just a few percentage points of changing and reducing drag has a big impact on our overall fuel consumption in the country.
Now, you did a special calculation for us so people could understand how much wind moves through the wind tunnel. Tell me about that.
I was trying to explain how much air that actually can move through the wind tunnel. And if you think about the air in your typical average house, if we operate our tunnel at full speed, you would change the air out in your house 100 times in a second.
Well, we'll be back with more NASA technology in a minute, but first we have the story of a local scientist who as a child would gaze at the stars through her binoculars and then grew up to work on the world's most powerful telescope.
We are go for main engine start, T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
There was a great deal of anticipation throughout the scientific community when the Hubble Telescope was first launched in April 1990. A project that had been conceived and in the planning stages for more than 30 years soon ran into problems, and NASA wasn't getting the photos that the astronomers had hoped for.
Okay, flight, I'll come back with the answer.
I need answers now.
It was not working. The telescope wouldn't point, it wouldn't track. When it did take pictures, they didn't look right. And our team really entered from the side with sort of a fresh view, analyzing just our images. And we were the ones who told the whole project what had happened. Do any of these galaxies lend themselves?
Dr. Sandra Faber is the chair of astronomy and astrophysics at UC Santa Cruz. A noted astronomer, she was awarded the prestigious 2009 Bauer Award and a $250,000 cash prize for achievement in science. The Bauer is among the nation's richest science prizes. While she spent most of her career studying, teaching, and lecturing about the cosmology of distant galaxies, Dr. Faber was one of the first to point out that NASA needed to fix Hubble.
Well, among astronomers, there was mourning, a sense of mourning, really. And NASA felt so embarrassed. What a tragic misstep, visible to the whole world after all this hype.
Eagle, go. Econ, go. Discovery, go for Hubble release.
I think, paradoxically, it brought out the best in everybody at this point, this massive failure, and we all had to pull together in order to make it right.
Okay, Charlie.
It took several years to come up with a solution to the problem, but in time, there was another space launch to repair the Hubble in December 1993. It was like putting corrective lenses on a large school bus that cost $1.5 billion. The first pictures from Hubble were blurry and looked something like this. Thanks to a number of scientists, the Hubble sees clearly now, and the results have been spectacular.
There was a ballroom full of 2,000 astronomers and eagerly waiting to see these new pictures. And it was a great moment for me. One of my graduate students was a leader here doing the presentation. They showed the before, fuzzy, and after pictures that were brilliantly sharp, beautiful. They had chosen objects to compare deliberately. It was fantastic. Astronomers stood up and cheered. It was just great.
Hubble was designed to be like your Honda or your Ford or your VW. It gets a tune-up every so often. There have been 5 repair missions to Hubble in the last 20 years, with the last one coming in May 2009. Hubble should be working until around 2014. Cross your fingers that your Accord or your Jetta will last that long.
It looks out in space large distances, and when a telescope looks out in space, it also looks back in time. It's called the look-back effect. That's because it takes a while for light to travel from there to here. So if you look at the sun, you're actually looking 8 minutes back in time. If you look at Jupiter, it's 40 minutes. Nearest star, 4 years. Hubble will take you 13 billion years back in time.
A look back in time also reveals that a young girl named Sandy, growing up in Ohio, fell in love with the stars.
I was a science geek as a kid. I was the classic science geek, but I was always the most interested in astronomy. And I never had a telescope, but I had binoculars, my dad's binoculars. I'd go out in the backyard, suburban Cleveland, lie down on the grass in the summertime and look up at the sky with the binoculars, star charts, reading books about astronomy. I was always an astronomy geek.
Faber obtained a BA with high honors in physics from Swarthmore College in 1966, and she went on to receive her PhD in astronomy from Harvard University in 1972. Along the way, Faber has continued to do research while working on the Keck telescope in Hawaii and her close involvement with Hubble. Despite a long and distinguished career, Faber remains passionate about science, the delight of discovery, and the joy of being part of a university.
Well, there are 2 things that are still driving me that I find just as interesting as they ever were. The first thing is that it's just a wonderful thing to discover something new. The other thing that has really been important to me is influencing other people. Because as a professor, you're in a wonderful position to mentor people.
Most of Faber's entire life has been spent studying the heavens. There is a long-standing and distant connection between a girl named Sandy in Cleveland and an Italian astronomer who built a telescope more than 400 years ago named Galileo.
The Galilean telescope was probably the most important scientific instrument in history. It told us that there was a universe out there and that we could understand it with the same laws of physics that we have here on Earth. Hubble continues in that tradition. It's a great leap forward for astronomers, but it brings these wonderful images that people can look at, and they can see the link between planet Earth and the wonderful universe out there. We're all one gigantic cosmic fabric. We belong in this universe. It produced us.
Welcome back to NASA. I'm here with Frank Hui. And as you can hear in the background, there's a large vacuum system working next door. It doesn't work here, but it's like what works here. Tell us about this, Frank. How big are these orbs?
We have 4 75-foot diameter vacuum spheres, and they are evacuated for simulating in the hypersonic wind tunnels.
And what do they do exactly?
Basically, they are on the receiving end of the wind tunnel to receive the air that's coming from the wind tunnel.
Okay, so the wind tunnel air just flows out of there and right into here.
Well, it goes to the test chamber first, then eventually wind up in the sphere here.
So what were these built for?
Well, they were built back in actually in the early 60s for doing a lot of basic aerodynamic research on hypersonic flows. And subsequently in the 1970s, during the development of the space shuttle, they were used heavily for simulating the space shuttle and the launch from the launch pad all the way to the upper atmosphere.
Wow. So what were you testing for? What did you need to know about the space shuttle?
Well, obviously there are a lot of the development had to be done in looking at the aerodynamic, the shape of the space shuttle, how it's supposed to be optimized for the different aspect of the flight.
Were there any changes made in the space shuttle shape due to what you learned?
I'm sure they probably did, but I wasn't here back then. Yeah.
Okay. We'll be back in a minute with more high tech from NASA. We're going to take a peek inside the vertical motion simulator. But first, let's meet Natalie Battaglia. She's a local scientist who's searching for inhabitable planets.
It wasn't that long ago. We can only wonder if there was life on other planets. And if so, what was it like? At the NASA Ames Research Center at Moffett Field, scientist Natalie Battaglia is trying to replace the planets of our imagination with reality.
Born and raised in the Bay Area and educated in the Bay Area, and here I am working in the Bay Area on NASA's, in my opinion, this is just the biggest thing NASA's got going on right now. The Kepler mission is a Silicon Valley mission. This is a Bay Area mission, and we should all be very proud of what's going on here.
Okay.
I was just looking at these unclassified stars. So
Battaglia is the Deputy Science Team Director of the Kepler Mission, a search for inhabitable planets in our galaxy.
By our definition, the fundamental requirement for life is the existence of water on the surface. So we look for planets that are not too close to their parent stars that water would boil away, and not too far from their parent stars that water would freeze up. There's this kind of Goldilocks zone where the temperature is just right for liquid water to pool on the surface. That zone we call the habitable zone. And it's planets in that region around its parent star that we're really giving high priority to.
T-minus 10, 9.
NASA launched the Kepler photometer in March 2009 in a quest to find planets that might possibly sustain life.
Engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
That's right, we have here now the new set of planets.
How do scientists spend their days at NASA? Well, Battaglia and her team review the information that keeps coming back from Kepler.
We've got a pipeline that analyzes that data and looks for dimmings in brightness that happen when a planet in its orbit about its parent star passes exactly between the telescope and the parent star, thereby blocking out some of the light from that star. And Kepler is able to detect a change in brightness that's about 20 parts per million. You know, imagine you had 1 million light bulbs and you took just 20 away. That's the brightness change that Kepler needs to be able to detect with high precision.
This past June, the Kepler team released its first catalog of planet candidates. The data indicates there may be a planet orbiting one of the thousands of stars Kepler is observing.
There are 700 of them. 700 of them. Even if half of them turn out not to be planets, we are still almost doubling the roster of known exoplanets in our galaxy with one publication.
Dr. Natalie Battaglia has been the co-investigator for the Kepler mission for the past 4 years. However, she wasn't always interested in a career in science.
Science isn't something that I thought about as a kid doing. I didn't know what it meant to be a scientist, really. When I took my first physics class, that really opened up the world to me. You know, to see how the universe can be explained with mathematics was profound to me. To know that the universe is not just chaos, that there's order.
Just like a lot of other kids, Natalie was inspired by the space program.
I think that the space shuttle program that the United States implemented in the 1980s had a profound effect on me. It was very interesting and compelling to me. And I realized in my early years of college, you know, that if I thought, what was my dream job? Well, to be an astronaut, you know, that's my dream job. So to work for the space program, to support the space program, I think was a seed in my brain that blossomed in college.
The person who ultimately ended up looking for life on other planets started as an intern at UC Berkeley.
In college, I had an internship that was very astronomy specific. And once I was exposed to science and once I took my first classes and understood what it really meant, I was hooked. It was just very, very compelling.
By the time the Kepler mission comes to a close in 2012, Dr. Battaglia and her team hope to have found planets similar in size and distance from their parent stars as Earth, planets that could possibly sustain life.
I'm a closet optimist. I think, and there's good scientific reasons to think, that Earth-sized planets are going to be common. It's going to be difficult to find Earth twins orbiting a star like our sun at exactly the same distance. That's going to be more challenging, but I'm optimistic that we're going to get there. We're going to be able to find an Earth twin out there.
The Kepler mission fulfills the human desire to explore the world beyond the borders of home, a spirit of discovery that Dr. Battaglia says is etched in our DNA.
To be able to look up and say, we're not alone. Not only are there other worlds out there like Earth, but there might actually be life out there like us. That's, well, what more profound quest could there be?
Maybe Ed Wood was right. Perhaps we aren't alone out here.
Welcome back to NASA. We are in the simulation laboratories, and this simulation system has several different kinds of simulations that can be performed here, and this one that we're inside is the space shuttle. And I'm with a former astronaut, Bobko, who's going to show us how this works and how he trained here. Thank you so much for bringing us into the sim lab. This is really interesting.
Yes, it's very interesting that we do spend a lot of time here. We also develop procedures and develop other things to fly the shuttle here in the simulator, besides training in the simulator.
I see. So astronauts come here to learn how to fly and land?
Oh yes. Yes, they typically come here, or they don't now because the shuttle program has been shut down, but they would typically come here a couple times a year to learn to go through the landings.
Not everything goes according to plan here, does it?
We try to plan for the worst, and we even have people who sit around trying to plan the worst because you want to be prepared if something bad happens.
So you're trained to, all the things that could go wrong are programmed in here, so you experience them?
Well, that's what you try to do. You know, you never can guess exactly what's going to go wrong, but you certainly make an effort to cover all the things that might go wrong.
So what kinds of things do go wrong?
Oh, blown tires, parachutes not working, navigation and guidance not working correctly. There's a whole list of things that could possibly go wrong.
Now, how many flights did you pilot?
I was a pilot on one and I was a commander on 2 flights. So 3 shuttle flights.
Wow. And so you landed and on some you were the pilot?
Yes. The pilot typically runs the systems and the commander actually lands the vehicle. So I landed 2 shuttles.
So can you show us how it's done?
Certainly.
Okay.
We have a 20-degree angle with the ground. We're running at about 300 knots, which is just a little bit higher than 300 miles per hour. We're going through 4,000 feet now. Now at 3,000 feet, you'll see the pre-flare cues come up from the bottom. Our touchdown point is going to be on the runway, just to the right of the red lights that you see down the runway. We're coming over the end of the runway and we'll bring the nose up. And so we'll just settle down onto the runway. You can see the touchdown. I'll put the chute out, put the nose down, coming through 100 knots. I'll go ahead and put the brakes on. I'll go ahead and jettison the chute so it doesn't get tangled up in the engines and things on the back of the shuttle. I've jettisoned the chute now, and we're coming to a stop.
Thank you so much for allowing us in.
It's my pleasure.
We'll be back with more from NASA, but first, John Gregg takes us inside the space station with local astronaut Greg Chamitoff.
Former President Dwight Eisenhower liked to tell the story that when he was a young boy growing up in Kansas, he would go fishing on a river with a friend. The boys used to talk about what they wanted to be when they grew up. His friend wanted to be the President of the United States, and Ike wanted to be a Major League Baseball player. Eisenhower also liked to point out that neither of their wishes came true. Dreams and wishes did come true for San Jose's Greg Chamitoff. He dreamed of becoming an astronaut, and through hard work, determination, and a little luck, he got the chance to fly aboard the space shuttle and also walk in space.
We took just a family trip to Florida for the summer, for part of the summer, and so we were watching in Daytona Beach when Apollo 11 launched, and so my father was explaining to me, what was going on, and we had already spent a lot of time watching Star Trek together, and I just decided I want to do this, and I told my family then I want to do that when I grow up, and they never discouraged me, so somehow it all came true.
Hey, you guys looking for? Hey, you looking for a plumber?
Chamitoff became an engineer and a NASA astronaut. He flew on 2 shuttles, the Discovery and the Endeavour, and spent 6 months aboard the International Space Station. Born in Montreal, Canada, he moved to San Jose when he was 11. His father's interest in the space program proved to be a catalyst for the aspiring space voyager.
He was an engineer, a mathematician, and I just remember that at that time, things were going on with the space program, and we would watch TV and see things happening in mission control, and as an engineer, he was just fascinated by how people got those jobs. He thought those were the coolest jobs in the world, and he wished he could have that job. He had no idea how somebody could have a job like any of the jobs in mission control, and so his fascination, was definitely an inspiration for me.
Chamitoff graduated from Blackford High School in 1980 and then went on to Cal Poly San Luis Obispo. He would eventually go on to earn a master's degree from Caltech and a PhD from MIT. But it was his first year of college that proved to be a difference maker.
The important thing that happened, I think, to me in college was the first shuttle launch happened in '81. And I saw the first shuttle flight, and it was actually the first time I called NASA. I called NASA and I said, okay, I really want to do this. I've always wanted to do this, but now's my chance to do the right things to make sure it's possible. What do I need to do?
The advice was simple. Work hard and be passionate about whatever you do. Chamitoff was driven in college, but he also had fun. And after getting his PhD, he applied to the astronaut program. One day, he got the call that everyone wants, but few get from NASA.
It is a very surreal thing to get word that you're selected, because it's a long shot for anybody.
What followed was a great deal of hard work and training for another year. Flight training, leadership training, survival training, underwater training, and training in different languages. And then, after a lifetime of waiting, he found himself on the launch pad for the first time aboard Discovery.
Getting to fly in space is a goal, and it's also a dream come true. But it all happens in a moment. Somehow there's a moment when either your dream comes true or it doesn't. And you get to that point, you're sitting there and the clock's counting down, and it could scrub any second, right till the last second. And if it doesn't, all of a sudden, boom, your dream is coming true. I've been thinking about this my whole life, and now here it is, and it's going to happen in 5 seconds, and then it happens.
Booster ignition. Auto 2, Discovery.
Auto. C3 at 104. I see a command and a roll. Houston, Discovery, roll program. I am LVLH.
And of course, the neat thing was I had 6 months on orbit then to, fully appreciate it, and soak it in and feel like I really lived up there. So.
Chamitoff would spend the next 6 months aboard the International Space Station, the first 4.5 with 2 Russian cosmonauts. And he got to know his celestial home very well in zero gravity.
Life up there it's really surprisingly comfortable. I was, if there's anything that's surprising about the whole mission is how adaptable we are, and as a species, I mean, and how comfortable it could be to live in that environment.
Astronauts put in countless hours working on various experiments, and they're always on the clock. When Chamitoff did manage to get a little free time, he was able to talk to his wife Allison and their 2 children, Natasha and Dmitry. Chamitoff also got some free time to play a little chess.
I guess that NASA noticed and the U.S. Chess Federation noticed, and then all of a sudden they were requesting that I play a game against these school kids. They were actually, I think they were grade 3 at the time, and I would play them and they would post their suggested moves on the internet and the world would vote on the moves. And I lost that game.
Chamitoff achieved a lifelong goal when he returned to the ISS for the 2nd time, and he got the opportunity to walk in space as he worked on the station's robotic arm. To do that work, he had to let go of the handrail, and in the act of letting go, he experienced an epiphany.
This handrail, to me, like represented, it's all I could see in with my light. It represented my family, my life, everything I knew, every place I knew, everybody on Earth, and it felt like the edge of the world, you know. And you know, I went back this way in the end, but it was just a spectacular moment. That'll always be in my mind, that one moment.
Dreams and wishes can be ephemeral, and they fly on gossamer wings for all of us, even for an astronaut named Greg Chamitoff.
Well, it's time to wrap it up. Thanks so much for joining us for this backstage tour of the NASA Ames Research Center. For all of us at This Is Us, I'm Becca King-Reed saying so long.
This is us.